So now we'll solve a differential equation. This is a real life reaction model. A chemical reaction causes a substance to decay at a rate proportional to the amount present. Initially, there were 200 grams of a substance, and after 10 minutes, 50 grams of them are remaining. So we have to find out the amount of substance remaining after t minutes and the time when only 10 grams remain. So why student find this hard is that there is a word problem plus differential equation. There's confusion between rate and amount. And they also forget, to how to apply the initial conditions, right? So we'll solve them step by step. We form a differential equation that is rate proportional to the amount, means this is a rate, dA divided by dt is equal to minus k a, okay? So there's a decaying problem. So A of t is the amount at time t, and k here is greater than 0. It's the decay constant. And the minus sign shows that it is a decreasing quantity. That the amount of substance decreases with time. Okay. And next, the first step would be to separate the variables. That is dA divided by dt is equal to minus k into a. So we separate the variable, which is dA divided by a. This is equal to minus k into dt. And then we integrate both sides. So we basically get natural log of a is equal to minus kt plus some constant. Now we convert this into exponential form. So you take the e power natural log of a is equal to e power minus kt plus c. So e and ln cancels out. A is equal to e power c and e power minus kt. Since e power c is a constant, so let's assume that this is c and e power minus kt. Now, this is a solution that amount of a substance is a function of time, right? Now we use the initial condition. That is, initially the amount was 200, so A of 0, that is equal to 200. Because it was 200 grams, so A of 0, 0 is 200. And then we substitute here A of 0 equal to C e power minus k into 0, which is equal to C e power 0, and which is equal to C. But A of 0 is 200, so C equals 200. Then A of t becomes 200 into e power minus k t, right? And then we use the second condition, that is A of 10 is equal to 50, and we put it in the solution, which is 50 equal to 200 e power minus 10k. So 50 divided by 200, this is equal to e power minus 10k. It cancels out with 1 over 4. And then we take the natural log on both sides. So ln of 1 divided by 4 is equal to ln of e power minus 10k. And this becomes natural log of 1 over 4 is equal to minus 10k, natural log of e, and natural log of e, this is equal to 1. Okay. So this is equal to natural log of 1 minus natural log of 4 is equal to minus 10k. It becomes 0. So k is equal to 10. Sorry, natural log of 4 divided by 10. So the final model becomes a of t 200 e power minus natural log of 4. So we substitute for k divided by 10t, right? And next we have to do when only 100 grams remain. So we set a of t is equal to, sorry, 10 grams. And we substitute for 10 in the previous equation. E power minus natural log of 4 divided by 10t. From this equation, we will work out for t. So 200, so here becomes 20, or 1 divided by 20 equal to e power negative ln of 4 divided by 10 into t. Taking ln on both sides, this become ln of 1 minus ln of 20 by using the property of logarithm. And here we will have minus ln of 4 divided by 10 t into ln of e, and that is equal to ln of e is 1. So t from here is equal to, and that goes to 0 as well, 10 ln of 20 divided by ln 4. So when you calculate this, so t is approximately equal to 21.6 minutes.